Okay, so just running through these real quick. I'm not going to tell you all of these angles up here, 1 through 4. I'll let you guys figure those. There's too many up there to repeat. But if you can do 5 through 8, then you should be able to get these right. So I'm going to give you 5 through 8. What was number 1 on 5? Yeah, 50. What's number 2? 130. Number 6, what is angle 1? 79. Angle 2? 101. Number 7, what's angle 1? 76. Angle 2? 61. Number 8, what was angle 1? 82. And angle 2? Say again? 122. Okay? Because if you get 98, you're looking at S and T being parallel, right? Because 82 and 2 would be, they are same side interior, but we don't get the same side interior being supplementary until the lines are parallel. And S and T we know not to be parallel because there's no, I guess we don't know that they're parallel or not. So we can't make the argument that we know automatically what 2 is. Does that kind of make sense? Okay. So we want to look at the fact that this is 58. That would be 58 where my cursor is. And then 58 and 2 should be supplementary. My argument to you guys is if we can do those, and we can answer those questions, 5 through 8, and even 1 through 8 then, you know the geometry. You know the relationships that our theorems are setting up. Now the questions that you're going to be asked on exams, and of course exams, tests, whatever, quizzes, are more like these. Okay? And the added kind of difficulty comes from the algebra, all right? But we're going to use the same relationships that we use to make the conclusions that we made in 1 through 8, okay? So as we go through these, I just want to go through the answers real quick, and then we'll come back and discuss any of them that you guys want to in detail. So number 9, what did you guys get for X there? Number 9, 103, okay? Number 10. I think you guys are, yeah, 24. So we're on the back. We're on this. I know they're out of order, but on my worksheet they're not. So my worksheet 17 and 18 are going to be at the end. So we'll get to those. So number 9 was 103. This one here, X is 24. What about X on number 11? 30. What about X on number 12? 75. Now this one has a Y in it too. What's Y? 110. Number 13, X is 13. What about Y? 6. Number 14, X is 16. Y is 40. What about 15? What did you guys do for X? Say it again. 25. And Y is 10. What about X on 16? 30. What about Y? 5. 17. What is X there? 31. And Y is? I got 45. But if you got 31 and you got something else for Y, then it's probably just a substitution error that you've made. So now we know the answer is which ones do you guys want to talk about? Which ones want to go through in detail? 15 and 16? 13 and 14? All right, so when we look at 15, and there's a couple, somebody in the line, this is the thing about geometry and just math in general. Someone in the last class brought up a concept, and I'm not going to explain it to you because it was kind of hard to get him to realize that what he was doing was absolutely fun, and the fact that I don't know that it's going to work ever again for him, but it did work on this situation. There's a lot of different ways of approaching these things, okay? I think the worksheet, though, is trying to target this idea. If I remove those, okay, what is the relationship that you guys are seeing between the two angles right here? They're same side interior angles, okay? So they should be what to one another? Supplementary, okay? Same side supplementary. So we got 2x plus y plus 120 should equal 180, right? Okay. The next thing to do then, so that has x's and y's in it, and that's a problem for us. So then we need to Look at the other set of angles. So I cover that stuff up. Do you now see the relationship between these two angles? What should we say about those two? Are they supplementary as well? So we should have 2x minus y plus 140 equals 180. Okay. Now the best thing to do with these types of equations, because neither we can solve for x or y right away numerically. So I think the best thing is to rewrite this as 2x plus y equals 60. Subtract that 120 from both sides, right? Can I take the blue one and rewrite that as 2x minus y equals 40? Does that make sense to everyone? Now, I would use elimination here. I think it sets itself up best for elimination. If you want to use substitution, by all means, go ahead and do it. Okay? But like I said, substitution, I think, is going to be a longer process here. If I add straight down, and this is why I would use elimination, I don't have to do anything to either equation in regards to being able to add straight down. I get 4x's, my y's eliminate, and I get 100, right? X has to then be 25. Now, what we need to remember is that once I have one of my variables, x or y, it doesn't matter which one you solve for first. Once I have one of those, all I have to do is plug it back into one of the equations previously found in the problem that incorporates that variable and the missing one. Okay? So my missing one is y. I'm going to go through and I'm going to use, I'll use this one. Plug in x. So I have 2 times x is now 25, so it gives me 50 plus y equals 60. That give me y to be 10. Okay? Just to prove that it doesn't matter where we put it in, I put it in that one. I get 50 minus y equals 40. I get negative y equals negative 10 when I subtract. Because y still give me 10. Okay? It doesn't matter which equation you plug back into, you're going to get y to be 10. All right? Now, is that the only approach? No. Okay, some of you saw this. Some of you said, let me clean this up a bit. Maybe you took this red one here and wrote it as y equals 60 minus 2x. Anybody do that? If y is equal to 60 minus 2x, could I come down here and replace that y in that equation with 60 minus 2x? So what that would look like would be 2x minus, this is the only issue that we have when this happens, is that because I substitute y with a quantity and it's subtraction, I need to make sure I put parentheses around my quantity because I want to subtract that whole amount. So it becomes 2x minus 60 plus 2x equals 40. How many x's do you have over here? 4. Can I add that 60 to both sides? Because it would look like that it would be 4x minus 60 equals 40, right? Add 60 to both sides, so I get 4x equals 100. Is that the same thing I got when I added those things straight down? Okay? So it's regardless of the approach that you take, you're going to get x to be 25. And that's the thing, guys, is geometry-wise, I think the worksheet is saying that there's really one way for you to do this problem. Okay? But algebra-wise, there might be 3, 4, 5 different ways. Okay? And as we come across some problems, there might be 3, 4, 5 different or geometry ways to set up our equations. And then there might be 4, 5, 6 different ways to do the algebra. Well, there's 5 ways based off of geometry to set the problems up. And there's 5 ways to solve those algebraically. That's a total of 25 separate ways of doing the problem. Does that make sense? Okay. You guys remember those questions like Susie has 3 pairs of shoes, 4 pairs of pants, and 5 t-shirts. How many different outfits could she make? And you just multiply those numbers together. It's called the fundamental counting principle. Tell you how many different combinations there could be. That's what I'm talking about here, saying that there could be 25 different ways to do a problem. Because there might be 5 different ways geometrically, 5 different ways algebraically. It opens the door to a lot of options. something that I think maybe we should start doing, okay? I'm not saying I want you to use this in place of the algebra, because there will be times where this is kind of taken away from you, but we have the ability to use some technology to help us get these answers, okay? If I create these two equations, and Desmos is a pretty powerful calculator. So is GeoGebra. My suggestion to you, though, is do not rely on this 100%, because when you get to the end of course exam, I don't have Desmos up here. Let me see real quick. This is what you get on the end of course exam for geometry, okay? There's no graphing aspect to it, right? So if I had one of these system equation questions, or just any equation in general I had to solve, this is not going to help me very much, okay? But the graphical kind of connection that we need to make from these systems and the algebra that we're doing is that these two things are both lines. You got a blue line and a red line. Depending on the calculator you're using, now I'm going to use Desmos. So Desmos is what we call an implicit grapher, meaning I can type it in just like I see it, and it will graph that line, okay? You guys know to write things in y equals mx plus b form, usually with you're going to graph in like a TI-83 or 84, okay? Those are called explicit graphers if I solve for y or solve for x. But now if I graph the other one, graph the red one, okay? So you got the blue one and the red one. I'm not going to change that color, but what are we solving for? We're solving for where these things meet. When we go by hand, algebraically, we're looking for that ordered parallel where my cursor is. If I click on one of these lines, you see that gray dot show up. Is that what we just found, 25, 10, algebraically? Okay? So you can check yourself every single time you construct equations inside these problems. You should be able to check yourself, okay, regardless of how many equations you make. And I hope that you guys are starting to do those things, okay? Use all aspects of what we know mathematically and algebraically to help verify our procedures, okay? So that's how we would do that one. Let's do, you said 16 as well. So 16, is it really any different of a problem? No, it should be kind of set up the exact same way. If we look at getting rid of that stuff there, get rid of that too. What would you say about these two angles right here if these lines are parallel? Supplementary, so we got 4x plus 2y plus 50 equals 180. And then what could you say, I'm not going to color over them, but what would you say about these two then? Yeah, 4x minus 2y plus 70 equals 180, okay? Now here's what this is just showing you what I would do if I'm struggling with systems, okay? I would come to Desmos and type in 4x plus 2y plus 50 equals 180. Type in 4x minus 2y plus 70 equals 180. I would graph those two things. I would see that I'm supposed to get the answers of 30 and 5 back. Does that make sense? X should be 30, Y should be 5. And now I'm going to go through the work to see if I can produce that. Isn't it such a more comforting kind of process if I know what my answer should be before I even start working? Okay, if you guys remember back to, I don't know if you guys ever witnessed this. You guys, when you had traditional textbooks, did you guys know that all the odd answers were in the back of the book? That's kind of something that happens when you have a traditional textbook. Odd questions are nice to have because I can check myself. What I used to do is go to the answers first, and then make sure that when I go through the work, I can produce those answers. Okay. So as we're doing this, I think that green one probably makes most sense to rewrite as 4x plus 2y equals 130. And the red one adds 4x minus 2y equals 110. You guys agree with that? So that's just taking that constant of 50 and 70 that's on both sides of those respective equations and add or subtracting them from both sides. The reason I would use system here is what happens right away? What happens to your y? Yeah, they cancel right away. So it gives me 8x equals, what, 240? How many times does 8 go into 24? 3. So how many times is it going to go to 240? 30. So now I'm going to go take that 30 and plug it back into maybe that green equation. You get 4 times 30 plus, hold on. We go 4 times 30 plus 2y equals 130, right? What's 4 times 30? 120. Move the 120 over. I get 2y equals 10, so what's y got to be? 5, okay? Now, I want to show you that, because this is just being thoughtful of the math that you see. Some people see this and say, I like substitution. Okay. When we do substitution, this is the way you were kind of traditionally taught this, is to solve one of these equations for x or to solve one of them for y, right? You don't have to do it that way. If you see this one here has a 4x in it, right? The green one has a 4x in it. Does the red one have a 4x in it? Okay. Let's take this green one and solve it for 4x. Would you guys agree that 4x is equal to 130 minus 2y? You see a 4x down here. Can I replace it with 130 minus 2y? So now I'm going to add 130 to both, subtract 130 from both sides. So give me negative 20 over here. And I'll add negative 4y here, right? What do I get when I divide by negative 4? You get y to be 5. Is that the same y we found earlier using a different route? What do I like about that? Well, now if I know what y is, come back up here, that makes this 10. Okay, so I got 130 minus 20, which is, actually, I make that whole thing, sorry, 2y, I make that whole thing 10. So now I get 130 minus 10, which is 120. And I have 4x here. Can I solve for x and get 30? And that's the thing, guys. I don't want to pigeonhole you and say you have to do it the way Mr. Fay said. There's a lot of different options. The more you understand about the procedures of substitution and elimination, open up more doors for you in regards to those options. Any others on here you guys want to talk about? 13 and 14, okay. So when I look at 13, we have to decide some relationships here, okay? Let's just say that I look at just the two angles that are up there right now. What's the link between those two angles? Same side interior. What if I looked at just the two angles up there now? What's the link between them? What do they create? They're supplementary. They create a linear pair, right? Okay. So with those two, and this is why I want to maybe do it with these two first, is some people see right away that 10x plus 8y plus 2 equals 180. But then they think, well, it's got two variables in there. I've got a problem here. And then they just kind of stop. Okay. We have to realize that if that happens, they're going to provide us somewhere else in the problem a relationship that allows us to kind of dissolve that problem eventually. So look at these two. These are same side interior, right? What's the link between them? They add up to 180. So 8y plus 2 plus 25y minus 20 should equal 180. Okay? So those are two equations that we can come up with in this problem. Now, those of you that addressed the blue one right off the bat probably never physically wrote down the red one, which is fine. Okay? But if you wrote down that red one, then you have to eventually, first, you have to eventually come up with that blue one. So when I add the blue one together, to combine like terms here, I get what, 33 y's, be minus 18. So I'm going to add that 18 to both sides, so give me what, 198. Okay. Divide both sides by 33. Okay? And that goes in there. 6 times 33 will give me 198. So give me y equals 6. Now, what most people I think would probably have done is, now that I know y is 6, would this be 6 times 8, which would be 48, plus 2 would be 50, right? So if that's 50, what does this angle here have to be? 130. So a lot of people probably had the 10x equals 130 equation. But if I already have this red thing, I should be able to get that 130 as well from just plugging back in here. I get 10x plus 48 plus 2 equals 180. And then just by moving that 50 over, you see you get 10x equals 130. Okay? So a lot of people don't think initially that they're doing the same algebra because they didn't write it down that way. But your thought pattern that you're using is going through that algebra if you didn't write it down. Okay? Is that helpful now, one? Okay. Let's look at this one over here. Again, it's the same idea, it's the same principle. In regards to looking at this stuff, I think it gets kind of jumbled with all these parallel lines. But does this parallel line up here even do anything at all? Nope. Okay. Now, if I look at maybe these two over here. Okay, so does this kind of break it down to one of those simple versions of this problem? What's the relationship between those two angles? Corresponding. So 4x minus 5 is 3x plus 11, right? We know corresponding angles should be congruent. Okay. Now, that being said, I now have to decide, I have to choose how to come up with a relationship to find y, right? Might be a couple ways of doing this. Okay. If I look at, let's get rid of that line there, and maybe this line here. So now we'd be looking at, obviously, the side lines being parallel and this middle one, the horizontal one, being the transversal. What's the link between those two angles? These are parallel, same side interior, right? So same side interior have to be, yeah, that'd be supplementary. So get those two equations from this problem. You know, some people might have said, well, I look at maybe the fact that this 4x minus 5 can be put down here. That's 4x minus 5 because they're alternate interior. And then looking at those two and say they're supplementary. That's a perfectly fine approach. It's still the same relationship. Okay. But now that you solve for x in this one, so x has got to be 16 here. Subtract 3x and add 5 to both sides. Can I come over here now and say that I've got 3y plus 1 plus, what, 64? 4 times 16 minus my 5 equals 180. I'll leave that up for you to finish that algebra, but it should give you y to be 40 when you're done. So, okay, I think, and this is just going off of a few people have come and asked me, maybe, you know, anywhere from 8 to 10 people out of the 73 of us that take geometry. They've asked me about these 3 questions, and I look at their work, and they haven't redrawn any pictures. They haven't done anything to try and get themselves to visualize the relationships, kind of like we do in class. Okay, I know that's a pain in the butt. I know redrawing the pictures is not fun. Okay, but it's not hard either. It shouldn't take that long to do, especially if our overall goal is to get the questions right. Right? Okay. So it's very, or use highlighters or colored pencils on top of this. I think it's going to allow you to make those connections a little bit easier. I'm going to stop there with that. We can